Hello everybody, and welcome to exercise 3 on page 16 of the workbook. Here's another example of graphically estimating or calculating values of limits. Okay, so let's take a minute to just work through this. There are a lot of parts of this problem. We're just going to be using the graph over to the right to figure out what's going on in each part. All right, so starting with part A, f of negative 2, no limit involved in that calculation. They're just asking us if we substitute in x equals negative 2, what would our y value out of the function be? Okay, well, negative 2 is here, and notice that the point on the function is actually sitting up here. That y value would appear to be at 1. Okay, so we're going to get 1 for that first one. Let's see. What about the limit as x approaches negative 2 of f of x? Okay, well, that's like asking us, if we take x values that are close to negative 2, what are the y values of our function going to approach? And that's a two-sided limit because there's no plus or minus sign after the negative 2. All right, so we're going to look at both the left and the right-hand side of negative 2. Okay, let's start with a number that's a little bit less than negative 2, maybe like negative 3. Find where our function is. It's down here. And if we slide towards x equals negative 2, we're going to be going this way. What are our y values approaching? Well, they're approaching the y value of that open circle, which would be, let's see, on our scale, it looks like negative 3. Okay, so that's what's happening from the left-hand side of negative 2. What about from the right-hand side? Okay, if we take a number that's a little bit bigger than negative 2, we'd be over here. And this time, to slide towards x equals negative 2 on our graph, we need to go this way. Notice that we're still approaching that same point, whose y-coordinate is negative 3. And so since we approach negative 3 from both directions, that should be the value of our two-sided limit. Okay, what about f of 0? Okay, so what would we get as an output value if we substitute exactly 0 into our function? Well, here's 0. And the point on our curve looks like it's down here. And that y value happens to be negative 1. Okay. And then we come to the limit as x goes to 0 of f of x. Okay, let's first clear away a little bit of the clutter here. And this is a two-sided limit that we're talking about in D. And so notice that parts E and F right below it are about the one-sided limit, so it's kind of more natural maybe to do E and F before we do D. All right, so let's do E here together. So that's asking us for the limit as x approaches 0 from the right of f of x. So we're talking about x values that are a little bit bigger than 0. Okay, so I'll take a number that's bigger than 0, maybe 1, find where the graph is. And if we slide along the graph towards x equals 0, we're going this way to the left. What are the y values approaching? Well, they're approaching this open circle, which just happens to be at about 3.5. Okay, what about f? Okay, well there, same idea, but we're approaching 0 from the left-hand side. So we'll take a number that's a little bit less than 0, maybe over here. Where is our graph? Well, it's actually down here. And if we slide in the direction of x equals 0, we're going left to right this time. What are the y values approaching this time? It looks like they're getting close to this point, which happens to be at y equals negative 1. Okay, so we're going to get negative 1 there. Okay, and now back to part D. Can you tell me now what that limit is going to be, the two-sided limit as x approaches 0? Well, the fact that these two numbers are different, we got different numbers from the left and the right-hand side, tell us that this limit does not exist. Okay, we don't get the same number when we approach from the left and the right side of 0. Okay, continuing, this is kind of a long problem, isn't it? So f of 2, asking us if we plug x equals 2 into our function, what's our output? Well, let's see, here's x equals 2. If we go up to our function, we have a point right there, and that looks to be at about y equals 1. Okay, what about the limit as x approaches 2? Okay, well there, we're asking what happens to the y values as we approach 2. Again, it's a two-sided limit, so we'll do it from both sides, starting with a value that's a little bit bigger than 2. We want to slide in the direction of x equals 2, which is going to take us back here. Y values appear to be approaching whatever that point is. And if we did that on the other side of 2, okay, took a number that's a little less than 2 and slid towards x equals 2, notice that the y values are approaching that same point here, and its y value appears to be 1. Okay, so that two-sided limit looks to be 1. We got that we were approaching the same point from both sides. Okay, and what about the limit as x approaches 6 from the right? Okay, so we want to take a number that's bigger than 6, so maybe 7, and we're already on our graph, and we want to slide towards x equals 6. That's going to take us back in this direction. We appear to be approaching this open circle whose y value is 1. Okay, almost there. And then the limit as x approaches 3 from the left. Okay, again, let's get rid of some of our markings here. Okay, here's x equals 3. And if we approach 3 from the left-hand side, we're going to take a point that's less than 3, and we want to slide towards 3, x equals 3. That's going to take us towards this point. Okay, what's the y coordinate there? That's not a terribly nice number, so we kind of have to estimate it. And I would say it's maybe about 1.75. You might disagree with that and get a different number. That's okay, and just take our best guess. And then what about the two-sided limit as x approaches 3? Okay, well, notice that if we take a number that's bigger than 3 and approach x equals 3, we're still sliding towards the same point, so we should get 1.75 again. Okay, wow, that was a lot of work, but I think we completed the problem.